Welcome to all. In this video lecture, I will discuss about the very basic concept regarding to the enzyme inhibition. So what the enzyme inhibition is? Enzyme inhibition is a process by which the enzymatic activity or the functionality of the enzyme is interrupted or inhibited by a special type of molecule. That molecule is known as an inhibitor. So basically in the conventional process that we know all, that if any kind of enzymatic reaction is going on, in that case what will be happen, the enzyme, suppose this is one enzyme and this is the active site of the enzyme, right? And it will this at this particular active site the substrate will bind. Okay, now here the substrate is this one. So this is the substrate and it will make the enzyme substrate complex. Okay, now it will make the enzyme substrate complex. Enzyme and substrate complex, and this enzyme substrate complex will be converted into the product and the enzyme will be released. So this is the free active site and this one is the product. This is the product and this one is the enzyme. So this is the normal process of the enzymatic activity, and this kind of conversion of the substrate is done by this active site of the enzyme. Now what the enzyme inhibitor does? Now here what will happen, the enzyme inhibitor, these are the molecules that can bind with the active site of the enzyme, and as a result of that, now this active site, it is not now free or available for binding with the substrate. There are some other inhibitors also that are very much similar, that are very much structurally similar to the substrate. As a result of that, it will go and bind with the active site of the enzyme. So this is a very interesting phenomenon. Okay, now what is the importance, biological importance of these inhibitors? Now inhibitors, actually sometime we can design the inhibitor for our interest. Okay, so if we consider that it is a very much powerful tools, or designing an inhibitor is a very much powerful tools by which we can see the activity of the enzyme. We can actually inactivate the enzyme, because in the normal process what will be happen, normal biological system, there are different type of enzymatic reactions that are going on all the time, and that reactions must be regulated. Okay, and by using the inhibitor we can regulate the enzymatic activity, right? Another importance is that we can design different type of drugs. Okay, so different type of drugs, that drug will go and bind with the enzyme and it will actually interrupt or disrupt the functionality of the enzyme, right? And also we can see the Km value and also the Kcat, that is the turnover rate of the enzyme. Okay, so different aspects are there based on which we can design our inhibitor. Okay, now the inhibitor, which will, suppose let's say this particular thing is the inhibitor. Okay, now once this inhibitor binds with active site, now what will happen, it is now not available, the active site is not now available. Okay, no availability is there for the substrate to bind with the active site. Okay, now after that what will be happened, this inhibitor can be categorized into different types, basically broadly in two types. Under these two types different categories are also there. So let's see one by one. So actually this is a very basic and overview video. Okay, I will just categorize the inhibitor in a very short way, and later on in the future videos I will discuss each of those inhibitors in very much details. Okay, now this enzyme will bind with the active site of the enzyme. This is one way of enzyme inhibition. So as a result of that, no enzyme substrate complex will form. rather it will form the enzyme inhibitor complex, right? So no product formation is done. Another type of inhibitor that can bind to another region of the enzyme, that is the regulatory region of the enzyme. Let's say this particular pocket represents the site where different type of molecule can bind and regulate this particular enzyme. Okay, so here the inhibitor can also do the same thing. If inhibitor binds to that particular pocket or site, that is the regulatory site of the enzyme, rather than binding to the active site, even in that case what will happen? Enzyme substrate complex can be formed, but it is not now converted into the product, because the inhibitor binds to the regulatory region, okay, though the active site is free. Now once the inhibitor binds to the regulatory region of the enzyme, now it will make some conformational change to the enzyme or active site of the enzyme. As a result of that, the enzyme substrate complex is not converted into the enzyme and product, okay, or substrate is not converted into the product. So this is the type of nature of inhibitor. And by by designing a particular inhibitor, we can also see the kinetics of the enzyme, right? And what is the nature of the active site, what kind of amino acids are there, what kind of reactions are going on, whether it is nucleophilic reaction is going on or electrophilic reaction is going on, that all the things we can actually see. Now let me categorize the inhibitor into two ways. So inhibitor, number one is reversible. Reversible inhibitor. Another one is the irreversible. Irreversible inhibition. Under this reversible inhibition, there are three categories. One is competitive inhibitor or competitive inhibition. Number two is non-competitive and last one is the uncompetitive. Uncompetitive inhibition. And here the reversible, in the reversible it can be categorized into four. One is affinity level, then number two is affinity level, and number two is the group specificity. Or group specific, rather better to say that. Number three is suicide inhibition or inhibitor. It is also known as the mechanism based inhibition, okay. And number four is the enzyme substrate analog inhibitor. So these are the categories, okay. That kind of categories we can see in the inhibitors, okay. Now here let me tell you a little bit about the reversible and irreversible, and each of those are in a very brief, okay. So reversible means, as the name suggests, that when the enzyme binds with the inhibitor, or when the inhibitor binds with the active site of the enzyme, then what will happen? This kind of bonding is done by non-covalent interaction. So in case of reversible, we can see non-covalent non-covalent interaction between the enzyme and the inhibitor. So it is not that much stronger in nature. We can easily dissociate the enzyme inhibitor from the enzyme by dilution. So here no any kind of specific strong bonding is occurred. Okay, so non-covalent bond, for example, your hydrophobic interaction, hydrogen bonds. Okay, those are the non-covalent bond, because we are actually regulating the enzymatic activity for certain period of time. After that we should recover the enzymatic activity, and we can recover the enzymatic activity by just removing the inhibitor from the enzyme. Okay, so this is how the reversible inhibition is going on. And also the inhibitor actually makes a different type of non-covalent interaction with this active site, right? So here no any kind of stronger or any means the del G value is not that much higher to separate the inhibitor from the enzyme. So in this case we can recover the activity of the enzyme by just removal of this inhibitor from the enzyme's active site. Now these are the categories: non-competitive, non-competitive, and uncompetitive. Sometimes this uncompetitive is also known as the mixed type of inhibition. Okay, so we will see each of those processes, each of those inhibition in details in the future videos. And this competitive inhibitions, in this case what will be happen, the Km value will increase and the Vmax remains same. Okay, now that particular thing we will see in a very much detail. And in case of non-competitive, that means competitive means the inhibitor inhibitor will compete with the substrate for the active site of the enzyme, that one single active site of the enzyme, right? So this is the kind of competitive inhibition. And in the non-competitive inhibition, what will be happen, in the inhibitor can bind to the active site, right, active site of the enzyme, and also the inhibitor can bind only after even after the formation of the enzyme substrate complex. Okay, so in that case Vmax will different and Km will be same. We will see in graphical representation how these things are actually going on, how enzymes are actually inhibited in different type of inhibition processes. Okay, and in case of uncompetitive means the inhibitor will not compete with the with the substrate, rather it will bind to the regulatory region of the enzyme and changes its conformational structural conformation in such a way so that even after the formation of substrate with the enzyme, the no product can be formed. So here the inhibitor, in case of uncompetitive, the inhibitor is not competing with the substrate to bind with the active site, rather the uncompetitive inhibitor bind to the regulatory region of the enzyme to change its conformation, right? And irreversible is just opposite to the reversible. Okay, we cannot retrieve or we cannot recover the enzyme's activity, because here the interaction is covalent interaction. Here the covalent interaction goes on between the enzyme and the inhibitor. Okay, it is very much stronger. We cannot separate the enzymes from the inhibitors. Okay, and here different type of categorization we can see here: affinity level and group specific suicide inhibitor. That is the most important for the exam purpose. For the exam purposes, this particular suicide inhibitor is the most important. We will see in detail. Affinity means active site contains different type of amino acids, as it is a protein in nature, and this active site will contain different type of protein amino acid sequences. And the inhibitor, what will do in this case, at the affinity level of irreversible inhibition, the inhibitor binds at a particular amino acid. Okay, so at a particular, it will choose only one particular amino acid where it will break the side chain. Okay, the peptide bonds of the side chain present in the active site, and make the bond with covalent bond with the inhibitor. Okay, so as a result of that, that particular chain is broken. Now the enzymatic activity is disrupted. Now specific, group specific. Sorry, I've just told the wrong thing. Whatever I told, that is true for the group specific. Okay, that is true for the group specific. Sorry for the mistake. So whatever I have told right now about the group specific, okay, that are about the group specific, not the affinity level. Affinity level means it will actually increase the affinity for binding with a particular inhibitors, where the substrate and enzyme complex cannot be formed. Even it is formed, that it cannot make any kind of product. Okay, and suicide inhibitor, what it does actually, in case of the suicide inhibition, it will actually conduct different kind of different type of intermediates. It will form different type of intermediates. So one of the intermediate will actually will make a particular radio, not radio level, actually it will form a radical. Okay, it will form a radical or free radical. Molecule is present on that particular intermediate. That intermediate will go and inhibit the activity of the enzyme. So that is the case of suicide inhibition or its suicide inhibitor. And last, that is the enzyme substrate analog. So basically the enzyme and substrate analog, when it is formed, now only at that particular that particular situation only the inhibitor will go and bind. Okay, and it resembles like the enzyme and substrate complex. So this is a very brief discussion about the enzyme inhibition. And if you like this video, please share it and subscribe my channel. So that's it. I hope it will helpful for your exam. So thank you.